Hi, this is your instructor Ehizis, and in this lecture we are going to proceed to create a dedicated game engine that will be used for the Flappy bird. The responsibility of this game engine is to run a background thread, and this background thread will consistently call our UI thread to update the graphics of the UI. To proceed, we have to create a new Java class called gameplay. Open up your Android Studio. Right-click on your package, Flappy bird. Go to New, Java class. We are going to call this class gameplay. Hit on your Enter key on your keyboard. This class is going to extend the superclass called SurfaceView. Extends SurfaceView. We are going to implement the surfaceholder.callback interface. Implement surfaceholder.callback. It is showing some errors simply because we have to implement some abstract methods such as surface created, surface changed, and surface destroyed. Check it out. Can you see that? So now click on the class and then alternate Enter on your keyboard. Select Implement Methods. Hit on OK. Perfect. As well, we've got some errors. So let's define the default constructor. Place your mouse right here. Hit on your Enter key on your keyboard. Right-click to generate constructor. Hit on Generate. Constructor. We have to select constructor with context as parameter. Here is it. Hit on the OK button. Beautiful. The errors are gone. Method surface created. This method is called when the surface view is created. For example, when you first load the application or when the application resumes from the background. In this course, we are going to use the surface created to create and start the main thread in order to begin the game loop. Method surface changed. This method is called when you want to change the size or orientation of the surface view, and will typically be used to redisplay graphics based on those changes. However, this method surface change will be left blank in this course because the app is always displayed on a portrait orientation. Method surface destroyed. All we do right here is to kill the thread. Alright, to try as much as possible to stop the thread. Haven't understood all this? Quickly, let's get started. Right in the constructor, we will initialize the surface holder. And I will call it my holder equal get holder semicolon to terminate it. Next, I'm going to do my holder dot add callback. So I'm going to take in this. Haven't done this, let's create the MainThread class. Squeeze it out. Right click on your package Flappy bird. Go to New, Java class. Now I will call this class MainThread. Hit on your Enter key to pick it up. This class is going to extend the superclass called thread. Extends thread. Go back to the gameplay class. Stretch it out. Let's define the object reference of the MainThread. Right in the class, I'm going to do MainThread, and I will call it MainThread, semicolon to terminate it. Let's instantiate in constructor. MainThread equal new MainThread, semicolon to terminate it, and I'm going to take in surface holder. Perfect. When our surface is created, we will start the main thread, and the main thread will help call the other threads running at the background. So let's do that. Right in the surface created, I'm going to do main thread dot set is running. We will set it to true, semicolon to terminate it. Main thread dot start. Perfect. Right in the surface changed. We are not going to do anything, so I just have to keep it clean. Alright, please do not delete it, because if you do, it's going to give you some headache. Right in the surface destroyed, we are going to stop our thread, but there will be multiple threads running concurrently at the background, and trying to stop these threads can be so difficult. Alright, so we are going to try as much as possible to stop it, but when it seems impossible, we will retry. So we will keep trying till we are able to stop all the threads. Understood? Let's do it. Boolean retry equal, we will set it to true, semicolon to terminate it, and right here we are going to have a while loop. Right in the while loop, we are going to retry. Open and close curly bracket, and right here I'm going to do main thread dot set is running. We will set it to false, semicolon to terminate it, and right here I'm going to do main thread dot join. With the help of the join method, the main thread will be on hold for the other threads to die out or finish its execution, and after that the main thread has to join. Alright, so it has to as well stop its execution. Definitely this is going to throw an exception, so we have to wrap it up in a try block. Come right here and I'm going to do try. Okay, I just have to highlight, Ctrl X to cut, come here, Ctrl V to paste. Cool. Down here I'm going to do catch, so it's going to catch an interrupted exception. Now I will call it E dot print stack trace. Cool. If all the background thread has died and the main thread has stopped its execution, we have to set the retry to false so that the while loop will stop its execution. Retry equal false, semicolon to terminate it. Let's clean up our code. Looks clean. Beautiful. Now we are done with the gameplay class. So let's go back to the main thread and finish it up. Main thread. The objective of the main thread class is to continuously refresh our screen as long as the condition remains true. Right in the class, here, right click to generate constructor. Hit on generate, select constructor. Make sure the thread is selected and then hit on the OK button. Let's define the surface holder object reference. Surface holder, and I will call it my surface holder. Semicolon to terminate it. And right here in the constructor, I'm going to take in surface holder. Surface holder. Cool, guys. Awesome. Actually, this will enable us to manipulate the canvas. Let's define the necessary variables in class scope. Right here, we're going to have long time spent. Friends, I want you to take note of the convention I used in naming this variable. It is called the comma case. It implies that you capitalize the first letter of every word except for the first word. Semicolon to terminate it. Now I'm going to do long kickoff time. Semicolon to terminate it. Long wait equal 31. This is the time it takes for our frame to refresh in milliseconds. Next, we are going to have Boolean running, and also we are going to have private static canvas, and I will call it canvas. Right in the constructor, I'm going to do this dot my surface holder equal surface holder. Set the variable running to true. Semicolon to terminate it. Having done this, we have to generate an override method called run. Type run on your keyboard. Hit on your enter key on your keyboard to select the first method. Get rid of the super. Cool. When the MainThread class is called, the run method will start its execution. While our thread is running, we will invoke the various methods in the Game Manager class that is responsible to draw all the objects to be displayed on the screen, such as the method to show the bed animation, tube obstacles, and the background scrolling animation. For this reason, we will introduce the synchronized block. Also, we are going to keep track of the time it takes for our frame to refresh in milliseconds. With the help of the surface holder, we will be able to lock canvas, unlock canvas, and post. Quickly, let's do that. We are going to have a while loop. Store the current time in the kickoff time variable. Kickoff time equal system clock dot uptime millis. Semicolon to terminate it. Set the canvas to null. Right here, we are going to have a try block. We are going to catch exception. I'm going to call it E. Then E dot print stack trace. Awesome. Let's lock the canvas in the try block. Canvas equal my surface holder dot lock canvas. Semicolon to terminate it. Next, we have to call the various methods in the Game Manager class that will be responsible to display the objects on the screen. One of these methods is the background animation. AppHolder dot get game manager dot background animation. We are going to take in canvas. Friends, this will give us a huge problem. You know why? We have so many threads running at the background. So trying to call a thread can be so cumbersome. For example, the Android system might be calling the UI thread, and while we are calling another thread. But with the help of the synchronized block, we will be able to target and call only one thread at a time. So let's wrap it up in a synchronized block. Place your mouse right here, hit on your enter key on your keyboard, and I'm going to do synchronized, taking surface holder. Open and close curly bracket, highlight, Ctrl X to cut, come right here, Ctrl V to paste. Keep your code clean. Whether there is an exception or not, when the try block exits, we definitely have to unlock our canvas. To do that, we have to check if the canvas is not null and then wrap it up in a finally block. Right after the closing curly bracket for the catch block, this is it right here. Hit on your enter key on your keyboard and then I'm going to do finally. Cool. So we have to check if the canvas is not null and then unlock the canvas. And also, we have to wrap it up in a try block. Let's unlock the canvas. Dot unlock canvas and post. Let's take in canvas. Cool. And right here, we have to catch exception. Catch exception. I'm going to call it E dot print stack trace. Cool, guys. The finally block is executed even if an unexpected exception occurs. Next, we have to track the amount of time spent in milliseconds. Right after the closing curly bracket for the finally block, this is it right here. We have to get the time spent. Time spent equal system clock dot uptime millis minus kickoff time, semicolon to terminate it. If the time spent is less than wait, we are going to pause the thread to make sure we update the appropriate time. So let's do that. If time spent is less than wait, scroll up and let me show you. Wait is 31. Now we are going to put the thread to sleep. And while the thread is sleeping, we will manipulate it immediately. So right here, I'm going to do thread dot sleep. Now let's manipulate the thread. Wait minus time spent. This is going to throw an exception, so we have to wrap it up in a try block. Right here, I'm going to do try. I just have to highlight, Ctrl X to cut, Ctrl V to paste it right here. It is going to throw an interrupted exception. Catch interrupted exception. Call it E. Right here, I'm going to do E dot print stack trace. Awesome. Okay, so now the question is, what is the difference between the join method and the sleep method? Take note, this is an interview question. It is so important. Okay? Cool. The sleep method. The sleep method causes the currently running thread to temporarily cease execution for a certain period of time in milliseconds, which is subjected to the precision and accuracy of the system timers and schedulers. The join method is used whenever thread execution depends on another thread completion. So this implies that the main thread has to wait for the other threads to finish its execution before its own execution takes place. In summary, in sleep method, you can decide the time exactly, but in join method, we cannot decide the time. Sounds good? Beautiful. Lastly, we have to return if the thread is running. So right after the closing curly bracket for the run method, let me show you. This is the run method and here is the closing curly bracket. Place your mouse right here, hit on your enter key on your keyboard. Public boolean is running. So we are going to return running. And right here I'm going to do boolean state. And I'm going to set running to state. Running equal state, semicolon to terminate it. Cool, guys. We are done with the game engine. Awesome. So this will be enough to refresh our screen, the speed of our application and all that. This is cool for it. This is extremely cool for it. So everything is fine now, and let's check it out one more time. Make sure your code is cleaned up. This is all for now, and see you in the next lecture. Take care.